Thank you for the invitation. I'm very happy to speak here. So I'm an assistant professor at Tilburg University in the Department of Medical and Clinical Psychology, the Netherlands. So my focus and my interests are more towards fear conditioning with humans. I realized only after seeing the program that I maybe should have specified that. But anyway, and so I tried to make the connection between associative learning and fear condition and anxiety disorders, fear, things like that. And so today I would like to say some more things about controlled and automatic processes in fear conditioning. So much of the talk is based on human fear conditioning. So I thought it might be perhaps useful to give a very brief primer to just clarify what I'm talking about. So typically you have a very simple paradigm where people are shown certain geometric patterns or other things, simple stimuli often on the screen, and that is then paired with a shock. And typically you have another stimulus that is not paired with a shock. And for human fear conditioning, typically conditioned responses are measured with peripheral physiology. So things like the startle response or skin conductance. So you can see an example here. You can measure people's skin conductance, and it's an indirect measure of anxiety or fear, or actually arousal. But within the paradigm, it typically represents fear or arousal. So this is, the work that I will talk about is mostly based on this paradigm. And the thing I'm interested in is related to different theories of the psychological processes that are involved in human fear conditioning. So you have actually two very different ideas. So one idea is that fear conditioning is mostly takes place very automatically. So some people believe that there are two levels of fear conditioning, with an emotional level that is relatively independent of a cognitive level, and then a cognitive level that's relatively independent of the emotional level. And in fear conditioning, the idea is that due to the pairings of CS and US, an association is formed. And whenever the CS later occurs, it activates this association, and there is no need for conscious feelings of fear or any other conscious processes to intervene. So it takes place largely automatically. Different people have challenged this view. Here is just one example if you're interested in reading more about it. So other people, they argue that it's actually these cognitive and these, emotional processes are not so easily to be disentangled. Additionally, also these ideas of what people believe that the processes that are involved in fear conditioning, they also shape what sort of interventions researchers and clinicians may want to develop to target fear. And so here is an example of one paper that made the argument that clinical interventions should be designed to target the unconscious survival or defensive circuits alone in order to achieve success in treatments. So yeah, these two different ideas of the processes that are in play that also result in very different ideas about how you can target pathological fear and anxiety. And so just one word on automaticity. Typically you have different features of automaticity. So a very common conceptualization is of Barge, and he argued that there are four horsemen of automaticity. So unawareness and intentionality, efficiency and uncontrollability. So those are four features to sort of assess automaticity with. A small side note is that not necessarily all these conditions need to co-occur with each other. So you can have some features of automaticity and not others. So they're relatively independent. And there may be additional aspects to automaticity. But regardless of these points, it's a general idea or a common idea of fear conditioning is that it takes place quite automatically. So meaning without awareness, without intentionality, efficient, and typically uncontrolled. And together with other researchers in Belgium and Netherlands, we have tested some of these ideas, and we also came towards the conclusion that actually control processes seem to be quite important for several, coming from several lines of evidence, and I will just discuss some of them. And I also enjoy these comics by Frank Krause. He's an American illustrator. And he has a nice book, Deep Dark Fears. And here is a nice example of fear that comes to exist without any automatic processes, or well, not necessarily without, but not in the typical way that it's conceived of within fear conditioning literature. So people can get informed about certain contingencies like picking your nose and a dangerous worm living in your nose, and that may suffice to install fear for several years in children or maybe even adults. So that's a nice example that also maybe more control processes or conscious processes are at play. But I have more direct evidence, so I will discuss some of my research in this area. So I've done some research on the effects of verbal instructions in fear conditioning. And there is also some research, not necessarily of my research, but some research on inferential reasoning that I just want to share with you. So effects of verbal instructions, just as with the comic that I just showed, verbal instructions can probably be enough to elicit fear. Of course, the example that I gave was quite anecdotal, but you already have research from the 1930s showing that verbal instructions are verbal conditioning. So you can instruct people that a green light will be followed by an electric shock. And you can see here in this very early evidence that it's already that can lead to increase in the number of skin conductance responses. However, the research in this area is quite scarce. So a couple of years ago, I did a Web of Science search on fear conditioning and instructions, but I only received 190 hits. It has been going up the last couple of decades, but there's not that much research being done still. We recently wrote a review reviewing 50 of studies in this area. So if you're interested in that, that may be one place to start. And we recently also investigated this a bit further. And the interesting thing is that in contrast to animal research with human participants, you typically need to instruct participants in laboratory tasks. So you can't just sit them there and then just ask them to do a task. You actually need to instruct them. But it's actually quite rare for fear conditioning studies to report the instructions that they gave to their participants. And we wanted to have a closer look at that because we believed that the instructions were quite important. So we actually systematically varied the instructions that we gave to participants before a fear conditioning task. So 1/3 of the participants, we had about 120 participants, I believe, so about 30-40 participants per condition. So one group was instructed that the square or the circle will sometimes be followed by an electric shock, and the circle or square will never be followed by an electric shock. So these participants were told beforehand, very specifically, which contingencies they could expect. In another condition, we told them, so you will see two different shapes appear, and one of them will be followed by an electric shock, and the other one won't be followed by an electric shock. So again, we gave them instructions, but a bit less specific. So we didn't specify the precise contingencies. And then in another condition, we did not give any instructions about the contingencies. So we just said that there will be two different shapes on the screen, and that they will also sometimes receive an electric shock. And so in this study, then they went through a sort of standard fear conditioning task in which a square or a circle was followed by an electric shock, and the other shape was not followed by the electric shock. And this was our data with skin conductance, so a physiological measure. And what is nice to see here is that actually in the instructions conditions, you can see much clearer, much better pronounced conditioned responses than in the no contingency group. So you can also see that eventually differential conditioning develops, but it's less pronounced and it goes slower than in the two other conditions. So that shows that verbal instructions are actually quite important in also in fear conditioning tasks, in simple associative learning tasks. Another nice demonstration of the effect of verbal instructions is also when you tell participants that contingencies will be reversed in the following phase. You also see that conditioned responses follow these instructions quite closely. So the dotted line, it indicates when we gave them the instructions that the contingencies would be reversed. And you can see that actually right away from the first trial, it's a bit subtle here, but the conditions responses reverse right away after giving verbal instructions about contingencies. So that shows that conditions physiological responses in humans, they respond quite sensitively to instructions. Another nice area I find for examining or investigating the role of control processes in fear conditioning is inferential reasoning. And there, Peter Lovibond and some other researchers have done some interesting studies. And I think this study is a particularly elegant one. So in this study, participants in a human fear conditioning study, they saw compound stimuli being paired with a shock. So for instance, two stimuli A and B that are paired with a shock, and then C and D, also two stimuli paired with a shock, and then a couple of control stimuli. Following this first phase, participants are then told A is safe. So that allows them to infer that if A is safe, then probably B must have been the stimuli causing the shock in the first phase. And D is a control stimulus here, so it has exactly the same learning history, but there is just no inference possible about this stimulus at this point. So you will actually want to compare later in a test phase B and D to each other, and you would expect that then participants in this study would be more afraid of B because it allows for the inference that B must have been causing the shock compared to D. And that's exactly what these researchers found. So both on shock expectancy ratings, but also on skin conductance responses, you can see that people respond to this simple instruction, and so the inferences that people can draw about it. And the nice thing is that you actually can do also the opposite inference. So you can do the same first phase with AB plus and CD plus, so these two compounds. And then instead of saying or telling participants that A is safe, you can tell them also that A is the stimulus causing the shocks and A was causing the shocks in the previous phase. And that then allows for the inference that B is actually a safe stimulus, and then D, there are no inferences possible. So again, you want to compare these two stimuli with each other. And the nice thing is that in this study by Yannick Baudet and colleagues, they found exactly the opposite pattern. So now participants were more afraid for D than for B. So this is results for US expectancy ratings. For skin conductance responses, the results were in the same direction, but they were not significant, unfortunately, due to a slightly too small sample, I believe. But I think these are really elegant paradigms to study the role of inferential reasoning in human fear conditioning. And then one counter argument that I've looked at for making the claim that fear conditioning typically takes place automatically is that fear conditioning does not require awareness. So there are quite a few studies in the literature showing that or claiming to show that. And I recently did a meta-analysis together with Iris Engelhardt, my supervisor at Utrecht, on this. So when we meta-analyzed this literature, we found a quite large effect. So HSG 0.5 or 0.49. So that's a quite average effect size. So differential responding, that was quite a sort of reliable effect size that we found there when we meta-analyzed the literature. However, a big problem with meta-analysis and other reviews of a literature is, of course, that there is publication bias, which can be quite dramatic in some literatures, including some of the psychology literature. And one way of examining that is using a P-curve analysis. So I'm not sure if everybody heard about that. So that's why I have this figure to illustrate what it does. So if this was developed by Simonson and colleagues, and they found out that typically in some literatures where there's a lot of P hacking going on or sort of massaging the data to get significant effects, you typically get these P curves that look like that. So these are different levels of the P values, so smaller than 0.01, 0.02, 0.03, and so forth. So until 0.05, and their prevalence, how often that they occur. And if people massage their data a bit too much, then you typically get these P curves like that. So there's a lot of P values in the literature that are just below the alpha value. So that actually shows that the literature is quite unreliable and that there's a lot of selective public publishing going on. And the other way, if you have a reliable effect in the literature and there's a certain effect size, your P curve should look like this. So they call this right skewed P curve. So there's a lot of very small P values, and then due to sampling error and things like that, you also have some larger P values. But in general, your P curve should be skewed to the right. And there's actually a simple app where you can generate P curves for test statistics in the literature. And we did that for the literature on unaware fear conditioning. And here the blue line are the observed P values and their distribution. And you can see that there are quite a lot of P values that are just below the alpha level. And there are a number of statistics you can do to check if there is evidence for evidential value or for publication bias. So if you test a simple binomial test, if there are more smaller than larger P values, you don't find a significant effect. So that would indicate a reliable effect in the literature, but that's not the case. On the other hand, you can also check with a binomial test if the P values are smaller than the 33% power curve. So that's not the P values, they are not, or they don't perform better than this green curve, this green power curve. So actually there is some evidence for publication bias in the literature on fear conditioning. So actually, and together with quite a number of other problems in this literature, such as trial order effects and quality of the awareness measures and so on, we actually find that there is very little convincing evidence that fear conditioning can take place without awareness. So you can read about that if you're interested in this paper. So to conclude about this first part, is the acquisition of fear really automatic? And actually this evidence has been reviewed repeatedly in the literature, and there's not so much evidence for that. So already in the 70s, people concluded that the data do not support the idea of unconscious automatic mechanisms in the conditioning of adult human beings. And also more recently, Mitchell and colleagues in behavioral and brain sciences, they concluded that there is no automatic mechanism that forms links between mental representations. Humans learn the causal structure of their environment as a consequence of reasoning about the events that they observe. So yeah, that was the first part. I wanted to review some of the evidence pointing towards control processes in the acquisition of fear. And now I would also briefly want to consider some evidence in the extinction of fear. So I also like this photograph. So it's a type of exposure session, and you can see that this girl is not completely at ease, but she's being exposed to a dog, a friendly Labrador. And that already illustrates the point quite well. That was also made by Stephen Hoffman. The view that extinction learning is a low-level process does not involve higher-order cognitive processes was an overly simplistic and misleading conceptualization. And it appears that extinction learning and exposure therapy involves higher-order cognitive processes. So there is some consensus about that. But still also the idea of automatic association formation and inhibition of conditioned responses is quite prevalent also in the extinction or in the literature on extinction of fear responses. So one example is inhibitory learning theory. And according to this theory, fear is suppressed by strengthening an inhibitory pathway and reducing TOS of the US. So that essentially looks like that. So memory after conditioning, that's a simple association between CS and the US. And then after extinction, you have additional association that suppresses the original association. And presumably this, or according to some theories, this also takes place automatically, this formation of an inhibitory association. So yeah, that leads to also some theorizing that an association that can so when an association is activated, the CS is activated, and that indirectly activates the US, and this activation of the US that then triggers a fear response. So that's actually a quite simple idea of conditioning that actually has already been disproven, I believe, quite a while ago. But still, it's a prevalent way of thinking about it. So it's essentially by thinking of the aversive US, so by activating it, thinking of it, fear is elicited. But also in the extinction and the return of fear, there is some evidence for the involvement of inferential reasoning. So a nice example of that is from a colleague, Amraz. She did a nice study, I believe. And in this study, people underwent a fear conditioning study. So they acquired fear for a square and a circle, and then it was extinguished in a subsequent extinction phase. And at the end of the extinction session, the control group, the experiment was briefly interrupted, and the experimenter came in, and he or she said, there was a technical disturbance, but this has now been fixed, and you can continue the experiment now. And in the inference group, the experimenter said the same, but then she or he also added, because of disturbance, no electric shocks were delivered in the previous phase. This has now been fixed, and you can now continue the experiment. And so this allows for the inference after this extinction phase that you did not receive any US administrations because of a technical issue. And once this is fixed, you can, of course, make the inference that you will get electric shocks again. And in this data, skin conductance data, you can see this clearly that people, based on this inference, their conditioned responses returned quite clearly, whereas this was not the case in the control group. So yeah, that was for me. I guess I'm a bit soon. Well, it's actually okay, but this was for me what I wanted to present to you. So some of our research on automatic and controlled processes in fear conditioning. So fear conditioning is likely not mediated by a fully automatic process, and some evidence for that is moderation by verbal instruction and the moderation by inferential reasoning of fear conditioning. Likewise, fear extinction is also likely not mediated by a completely automatic process. Some evidence for that comes from the moderation by inferential reasoning. And for me, I'm working in more a clinical department. So for me, the interest in this research is that greater attention should be given to inferential reasoning processes in both procedures. And I think that will give us a better understanding of the way in which people acquire and also extinguish fears. And with this take-home messages, I would like to end my talk by thanking you for your attention and also acknowledging funding for a lot of this research done by me and also my supervisors, Iris Engelhardt and Jan de Houwer in Utrecht and Ghent University. This was also supported by grants from the Dutch Science Foundation and by Ghent University. And so thank you for your attention. And if you have any questions, feel free to ask them, preferably in English because I don't speak Spanish. Thank you.